Hello and welcome to demo number 2 for Team B's application, Personal Health Electronic Record, or PHER for short. My name is Iris Perry and I am the team leader for Team B. Our team consists of myself, Anthony McAlpin, Austin Holscher, and Isaac Nevarez-Saenz. As in Demo 1, our introduction and project motivation remain the same. When we were brainstorming ideas for our application, we saw a need for patients to be able to maintain and transfer their own data between their various healthcare providers. Currently, patients depend on the medical institutions they visit to store their medical records. Transferring data between these institutions is difficult because of time constraints. The institution's record keeping systems could be entirely different, and there are many hoops to jump through with faxing paperwork back and forth between these offices. We propose that our mobile application, Personal Health Electronic Record, or PHER for short, allow patients to track their own medical records, including records such as exercise activities, appointments, and medications. Patients should be able to easily share this information with their doctors in medical settings. For our customer problem statement, we start with the patient side. We have two patients, Paul and Patrick, who both had issues managing their healthcare records. They were tasked with combining large amounts of health information because they visited many different healthcare institutions. Since Paul and Patrick are both patients, these institutions did not give them direct control of their personal data. They required Paul and Patrick to spend their time and money jumping through hoops to get them to send their information on to their new doctor. Our solution to this problem will attempt to reduce these time and money costs to the benefit of both Paul and Patrick and other patients who use our application. Now we move on to the provider side of the customer problem statement. We have two healthcare providers, Paulina and Patricia, who both have issues managing health records for patients because they included records from other institutions, and these institutions store patient data differently than they do. Since Paulina and Patricia are new providers for their patients, they may not always get their patients' information from their previous institutions efficiently. Our system specifications remain the same as Demo 1. Our functional specifications include the ability to create, read, update, and delete medical records, including appointments, activities, and medications, send notifications of appointments to the users, generate statistics about their activities for the users, allow the users to securely log into our system, and allow patients to share data with their providers and allow providers to view this shared data. Our non-functional requirements also remain the same. These include the private storage of medical records in our own database, the ability to handle requests from multiple users, and a quick response, especially for recent records, for our patients to review them. Our user interface requirements also remain the same. These include the ease of use in using all CRUD functions mentioned earlier and the ability to view the application differently if you are a patient versus a provider. This brings us to the program execution segment of our demo. First, I will show you the small user interface changes that we've implemented since Demo 1. We rerouted the application to bring users straight to the login page instead of to the patient dashboard. After logging into the application, the user is brought to either the patient dashboard or the provider dashboard based on their role. The patient dashboard includes a calendar of their appointments, their pending and active share requests, and their weekly activity goal progress. The appointments, activities, and medications tabs remain the same. We have also implemented a logout button to allow users to log out of the application after they finish. The provider dashboard includes an option to request a patient's record, the provider's pending requests, and which patients are actively sharing their record with them. I will now turn the presentation over to Isaac, who will explain how sharing records with providers works.
Now I will demonstrate how to use the application to share patient data. To begin, I will show you the profile for Amy Loft. She is a provider and she's very active. She has sent 4 requests to patients, 2 of them are pending, and 1 of them is active. That means that she can view the information of a couple of patients. This is what appointments, activities, and medications would look like for a provider. And this is what it would look like when a patient is not actively updating their profile. So to demonstrate how all this works, let's go to a provider that hasn't submitted a request yet for information. In this example, let's use Michael Keys and send a request. We'll go to Michael's profile and reload the page and see that there's a pending request. Now, the provider can cancel this request before the patient accepts or declines, but also patients can make that choice for themselves. So let's send the request again and give Michael the chance to make a decision. Now they would like to decline. When we go to Stephen Brown's profile, the request is gone. Now let's send the request again. But this time, Michael Keys is going to accept. When we go to Stephen Brown's profile, now the information is available to the provider. Let's send another request to Michael Keys using a different provider. We'll go ahead and accept it. We'll see that it was accepted. Now, we will stop sharing information. We'll go back to the provider profile, refresh, and see that the request is gone. Thank you.
Now we move on to the testing portion of demo number 2. Our testing for our application remains much the same as demo 1. As of demo 1, we used ViTest to implement unit tests for all of our CRUD functions for appointments, medications, and activities. Since then, we have implemented new tests to test the goal progress function for activities and the get functions for our provider dashboard to ensure our application is sharing records correctly. I will break down one of these new tests, the test for goalprogress.js. Goal Progress dynamically updates the patient's dashboard and their activities page with how much of their weekly activity goal they've completed. First, we add a mock DOM element named Goal Progress to the document. We then mock the user ID in session storage. After this, we mock the fetches from the database to simulate successful responses. This mock returns 150 for the goal and 90 for the weekly progress. After we finish mocking these responses, we clean up the DOM using after each and restore all the fetches and session storage. We have 2 test cases that we are testing. The first should show the correct goal response we just mocked and show that the user has completed 90 out of 150 minutes of activity this week. The second test case tests what happens if the fetch from the database fails. It should show that there was an error loading the goal progress and an error was logged to the console. These tests are useful because they ensure that the user interface gives accurate feedback based on the user data. They also catch issues with the fetches to the backend or if we are missing DOM elements. This makes our development safer and we can run the tests again after changing things in our application. To run our tests, we must first start the server by typing nodemon server.js in a terminal window in VS Code. After the server is started, we open another terminal window and type npmt to run our tests automatically. This will run any test that has a test.test.js file name in the current directory. As you can see, all of our tests are currently passing. We only implemented unit tests for our application because we only had a need to test one component at a time. Most of our components are separate and do not interact with each other. The functions we are testing also do not rely on external frameworks like React, where integration between these components would be important. I will now turn it over to Anthony to explain our automations with activities.
This is our activities page. And 2 of our new features that we've implemented that the system will automatically calculate for the user is our first is the average exercise per day within a given time frame. So you can pick the start date here and the end date. And as you can see, April 30th to May 7th, the user has 23.33 minutes per day. If you go through our table here of our logged activities, you can see our 3 days in that time range for a total of 70 minutes. So 70 minutes across 3 days, and that's where the user had 23.33 minutes per day of exercise. If we wanted to shorten that time frame, we could bring it from April 30th and move that to the 5th. We'll take out that May 4th date. And this is an average of 30 minutes per day, 60 minutes total across 2 days. Another thing that we added in is our goal. So we can set a weekly activity goal that the user selects. Right now it shows my goal is 100 minutes per week. And I can change that to 50. Goal gets updated and it shows that we've completed this. We did this starting on Monday and ending on a Sunday. So as you can see, we have the 5th, the 6th, and the 11th. Those are our 3 days this week. It began on the 5th and ended on the 11th. I know the 11th is in the future, but it's our current week, and I wanted to show that it will still be accurate for that end date. The goal set by the user is set through the users table, and we even have it on the home dashboard as well. It shows that right here, our weekly goal progress, I've completed 70 minutes out of my goal of 50 for this week. So on our dashboard, it gives us a little snapshot overview of it. And then on our activities page, we can go in and actually edit that. And we can go to our users database and our user ID 32. This is the one that we were just looking at. Shows our activity goal of 50 minutes. And that matches up with what we wanted right there. Now, if we changed it to 100 minutes, update the goal, pull our database back up, and right here you can see it's been updated to 100 minutes. Now we can go ahead and switch over to our code for these new activity features. This is our front-end logic where the user will be able to put in their date range that they want and be able to get their average. Then we go over to our activity routes, and this routes us over to our activity controller. This is our part of our back-end logic here. Our activity controller has our get average activity function, checks if our dates are provided, and make sure if they're not, that they'll get a message to put that in. Then this brings us over to our activity services, where our get average activity pulls the user's inputted activity from the database. Now switching over to our user goals, our front-end logic has two files, our set goal and our goal progress. Our goal progress, this is our function to ensure that we're always in the current week. That way the user is never getting information from past weeks and getting the wrong information that they're looking for. Our backend logic starts with our user routes. We have our get and our put requests from our user controller. The first one is our get activity goal, and this will get the user's inputted goal that they've put in. And to update and set the goal, we have our set activity goal function. That brings us over to our services, user services file, where we have our get activity goal from our database. And then we also have our set or update activity goal for the user to be able to update their goal in our database. We decided to do everything for the goal through our user backend logic. We kept it organized that way. because everything related to the goal is through our users table, as we saw earlier.
Okay, so I'm just going to do a quick demonstration of our notification system. So I implemented the node mailer package and the node cron package, just essentially set up a cron job. And how we have it set up in the application is that at midnight, the cron job will search the database for any appointments that are scheduled for that day and send out an email as a notification and just a reminder to the patient that they do have an appointment that day. For demonstration purposes right now, since it is not anywhere close to midnight, I'm going to go ahead and just change this to every 5 minutes we'll have the job run. And right here we have a patient, and I'll go ahead and create an appointment for today. Okay, so now there's a dentist appointment at 5 p.m. today. And so in the next 5-minute increment, which will be in a couple minutes here, that notification will get sent out. We will see a message appear in the console to let us know that it did send, and then I'll show you guys the email inbox for the notification. So I'm going to pause the video for now, and I'll come back in just a minute. Okay, so I'm back, and the email will be sending in just a few seconds here. Yep. Running appointment check. And then message was sent. And it looks like there's another user that also has a appointment for this day. So there are 2 emails sent out. So I'll show you one. All right, so here is one of the emails. And after a refresh, here is the notification. So, hello, Carl, you have an appointment today with Dr. Bard at 5 p.m. And that is our notification system.
Now let's talk about future work. In the future, we would like to implement features that allow users to schedule appointments directly between providers and patients. Hopefully this would make everyone's life easier. We would also like more user feedback about the notification system that we currently have. It'd also be interesting to collect diet information and perhaps generate statistics. Maybe this information could be useful to patients and providers rather than just having raw data. We would also like to finally implement the progressive web app, the PWA, and perhaps we could have some type of personal assistant that could help with setting goal reminders, provide encouragement statements, and make activity suggestions. Project challenges include time management. Often than not, we were updating the code close to the deadlines, which left a little bit of time for others to review. Another challenge was version control. Sometimes there were minor bugs that interfered with other teammates' work. Fortunately, these were minor, and we had the skills necessary to troubleshoot these issues. And fortunately, again, nothing was severe. Another project challenge is that communication often is not immediate. We work at different times, we complete work at different times. So oftentimes, people would respond the next day, or you would see the response the next day because you could answer today and they won't see your response until tomorrow. And another issue that we had is that once we had a lot of the implementation going on, we had to create just fake data. And this was for testing purposes. In conclusion, PHER is designed to help patients track their health instead of depending on healthcare institutions. The current implementations include reading, adding, updating, and deleting data. We can share data between patients and providers. We can set goals. We can average data. This application will improve communication between patients and members of the healthcare team, and it's been a pleasure. Thank you.